Hello, this is Boha here. Today we're going to talk about some kinematic problems. So this is our today's schedule. We had two problems here. One is the typical dynamic problems, and the second one is the uniform circular motion. So let's talk about the dynamic problem first. Okay, so we have information in this problem here. It says two heavy creds M1 M2 which are separately over here and here on different inclines with angle 18 and 33, and we can see 18 is for M1 and the 33 degrees is for incline for M2, and we have the mass of M1 which is 426 kilograms. And don't forget that the small g is equals to 9.81 newtons per kilograms. So this is the condition that is given for question 1. And let's move on. So for solving kinematics problems, what we need to do first, we need to analyze the free body diagrams for each substance. So over here, I redraw the diagram on the paper and we can analyze for M1. So it has FG1 here to point towards downward, and the FN1 force on normal, which is rectangle to the surface. It points towards here, and the force of tension, which is along to the right. Since it's been tied up to the right side. And for the second craft, it is over here. It only has force on normal points upward against the surface, and the force of gravity, which is points right downward, and force of tension towards the rope. So over here we have the basic information diagram we need, and now we need to separate them. Since they have an angle over here, it's not a very good diagram if we just use this. So we combine it into, we turn it a little slightly, we turn it into this form, like this one. So in that case, so this should be FG1. And this is the 18 degree, and we simplify that. It could be this into FG1x, and this is FG1y. So in that case, the free body diagram on the normal way, which could be analyzed easier into this one. So we had the force of normal points towards up, and the force of gravity y cosine 18 is points downward, and for the left side it only has the force of gravity x sine 18, and 2 points right it's only force of tension. Same for the second mass, it is over here. And however, we can see that it has the gravity points downward with the incline of 33 degrees. In that way, we need to turn this diagram to left, so that we have a normal form of this free body diagram. In that case, since the gravity should after being applied should be like this, therefore we have this form of force of gravity y direction, force of gravity to the x direction, which is point separately downward, and to the right direction, which is point right over here and here. And we have force of normal and force of tension over here. So after we combine these all together, it became like this. Since the force of tension 1 is equal to negative force of tension 2, it cancel out each other. So what we have only left is on the y direction, on the x direction is FG1 sine 18 and FG2 sine 33. And after we combine these together on the y direction, it should be only left for fn12 combined and fg1 cosine 18 and fg2 cosine 33. Okay, after we analyze these questions, we can move on and solve the problem. So for question A, it has been asking for the force of tension, and the given conditions are M1, which is 426 kilograms, and the small g, which is equals to 9.1 joules per kilograms. And let's move on and solve the question. What we use now here is the force analyzation on the x direction. So therefore, for the x direction for only M1, it should be only force of tension and this force of gravity x for sine 18. So when this comes, it equals to F force on net x equals to F force of tension 1 minus force of gravity sine 18, which equals to 0 here. And we use this equation. Since we already know what Fg1 is, we just substitute into this equation, and we have 291.4 newtons for force of tension. Therefore, we solve question 1. Okay, and we move on for question 2. From here, we have been asked to solve the mass of M2. Since we already knew that the system is in a state of equilibrium, it means it's constant, so nothing here is moving. Therefore, we came back to this force of analyzation. We can see in the downward part, we combine these all together. On the x direction, there's only Fg1 sine 18 and Fg2 sine 33. So in that case, if it stays in equilibrium, these two forces equals. Therefore, we substitute into this equation. Fg2 sine 33 minus Fg1 sine 18 is equals to 0. Therefore, we can see that since F equals to Ma, therefore M2G is equals to 1291 newtons over 33 newtons. Therefore, M2 is equals to 241 kilograms after we solving this equation. And we solve question B. Then we move on for question C, alright? So in question C, we have been asked to determine the magnitudes of the acceleration. Now the conditions are changed. M1 is still 426 kilograms, but the mass of M2 changed into 195 kilograms. So in that time, the state of these two craft is not equilibrium anymore. It starts to move to the left side. Therefore, we can see that on the x direction. Alright. On the x direction, this Fg1 sine 18 is larger than Fg2 sine 33 now. So therefore, they are being asked to determine the magnitudes of the acceleration. So in that case, we analyze what we have, which is M1 is equals to 426 kilograms M2, and small g, which is 9.81. We'll be asking for acceleration. So what we use, the equation that we use is equals to F equals to Ma. Since we knew that the Fn on the x direction is not equilibrium anymore, it still equals to this. The chart that we analyze is equals to Fg1 sine 18 plus Fg2 sine 33, and we substitute what we have over here, which we use 426 kilograms multiplied by 9.81 sine 18 minus 195 kilograms multiplied by 9.81 newtons per kilograms multiplied by sine 33. After we analyze all these together, we can see that can see the force on net on the x direction is 249 newtons. Alright, we have this number here, but it should be points towards the left direction since we know that it is. Since we already know the net force is moving towards left, therefore the F net should be on the left direction as well. So we can write it minus if you want. Therefore, we already have force on net, and we need to use the equation since F equals to ma, and we need to know that what acceleration is. So a equals to F over m, which equals to negative 249 newtons over the m1, 2 combined. Alright, since acceleration 1 is equals to acceleration 2 equals acceleration combined, we just use, and we already knew this, negative 249 newtons is the force on net on 1 and 2 combined, and we just substitute these numbers in, and we have 0.4 meters per second squared to the left direction. Okay, and we saw this question successful. Let's move on for question 2, alright? So this one is easier one. It is a circular motion problem. Suppose Earth turns with a greater rotation speed. Determine what the period rotation in hours. This is asking for the 10. This is asking for t, which is the frequency combined. It is related. So in this time, we need to ask for in hours must be the centripetal acceleration equals to g. The radius at the Earth equator is 6,378 kilometers. Alright, so we know that the question is asking for the period, which is t. Now we move on. So according to the given conditions, the small g is equals to 9.1 meters per kilogram, and he is asking, we already knew that this acceleration for the Earth, which is 9.81 meters per second squared. It should be negative first, but we will explain that for a little bit of time. And the radius is 6,378 kilometers. We're asking for the period on time, right? And according to the equation given for uniform circular motion, we found that the acceleration is equal to 4 multiplied by pi square r over t square is the most fit because it has all the conditions combined. Therefore, we substitute the t square is equals to 4 pi square multiplied by 6,378 kilometers over 9.81 meters per second square, which means t squared is equals to 25,667. Alright, this time we need to explain why we use the acceleration as the positive one. Since t squared need to be positive, we cannot use the negative one. If we use negative here, it is negative this thing, which doesn't exist. So we cancel it out. And therefore, we calculate that the t squared here, t is equals to positive or negative 160. Since t is a period, it is a quantity. It must be larger than 0. Therefore, we assume that the period is equals to 160. All right, and we solved the problem here. Thank you for your time, and goodbye.